These are all some random questions. Depending on the nature of the series, you need to choose an appropriate method. So if let us first recall what methods we have, and then on what basis we can select a particular method, right? Let me just go ahead. Let me spend few minutes on that, and then I'll also communicate to you. See, when you are given a series, the first and foremost thing everybody should observe is whether the given series is, I mean, it's a series of positive terms or an alternate series, right? The first point to be observed is whether the given series is positive term series or an alternate series. You need to just observe this first. In case if you observe that as what you call a positive term series, when it is a positive term series, we have three options exactly. You can solve the problem. I mean, you can evaluate the convergence of the series by using what you call comparison test. If not that, you see, we can use what you call ratio test, D'Alembert's ratio test. If not this, you see, we can also use what you call nth root test. In these three possible ways, you can find out the convergence of the given positive term series, right? Recall in which case we can use either of these three tests. Let me come from the last one. See, when you are given a series, it will be something like, summation un, right? Understand it's a positive term series, and it will be given like this. When you are given summation un, look at the nth term initially. After identifying whether it is positive term series or alternating series, the next step is to identify the nth term from the series, right? We need to identify what is the nth term. Now see, after identifying that, if you understand this un as something whole to the power of n, right? If un has a function such that, something whole to the power of n, you may have anything here inside. If you can find un with this kind of expression, then nth root test is the most suitable test in that case. Okay, even such problems can be solved in other tests, but nth root test is the most suitable solution, most suitable method to find out the convergence. Whereas you see, when you find un, if you get un as something like, for example, if un has these kind of expressions like, n factorial, or n to the power of some finite number, or something like x to the power of n, if you have these kind of expression in nth term un, then ratio test is the most suitable test in this case. When your nth term in the series has either of these expressions, then you can use what you call ratio test to find out the convergence, right? In simple way, you see, if a test cannot be solved in either of these two cases, in most of the other way, you can use what you call comparison test. But you see, to remember, look at this way. When un, for example, if it has some fraction, looking at the rational function here, if the degree of denominator is more than the degree of numerator, for example, if it is something like this, n divided by n plus 1 into n plus 2. See, for some series, if this is the nth term, looking at this, one can easily understand the degree of numerator is 1, but the degree of denominator is 2. Right? When you have these kind of expressions, then comparison test is most suitable. Moreover, you see, look at the individual terms here. Right? Sometimes the degree may also be similar, but look at individually these expressions, n plus 1, n plus 2. When these are all linear expressions, see, the degree of each individual term here is 1. When they are all linear expressions, then also, see, comparison test is most suitable. Okay, if you recall what we do in comparison test, to solve a problem in comparison test, we need to find out one auxiliary series vn, right? When you choose this vn, we must know whether it is convergent or not already. This is what you call a known series. When you can decide a known series vn, then we'll just define this limit n tends to infinity, what you call un by vn is equals to some finite value which is not equals to 0, right? If you can get this kind of finite value, then we say both vn as well as un behave alike, right? So that's how you can decide whether the given series is convergent or not. Then when you use what you call ratio test, so here we just define, one particular limit n tends to infinity, un plus 1 divided by un. If you get this as, some finite value, and depending on the value you get here, you see, we'll decide the given series is convergent or divergent. I mean, if this limit is less than 1, we say the given series is convergent, and if this limit L is more than 1, we say the given series is divergent, and if L is equals to 1, we say the test fails. In a similar way here also, we'll use, a similar limit like this, limit n tends to infinity, un to the power of 1 by n. Right? When you have this power n here, and if you take the nth root of that, n will be cancelled out, and we'll get only a simple function. And then for that, if you take the limit, you may get it as L. Again, as in the case of ratio test, if this L is less than 1, we say the given series is convergent, and if L is greater than 1, we say the series is divergent, and if L is equals to 1, it is, the test fails in this case. So like this, using either of these three techniques, we decide whether the given series of positive terms is convergent or divergent. Now see, in case when you are given an alternating series, see, remember, when you are given an alternating series, alternately you will find plus minus symbols. Then, for example, if you are given the series as summation un, then immediately you need to choose what you call the series with absolute terms. Series with absolute terms. In the sense, we need to take it as summation mod un. Though some of the terms in the given series are negative, still we need to take them as positive only. We take summation mod un. After identifying this positive term series summation mod un, again using either of these three tests, comparison or ratio test, or again what you call nth root test. Using either of these three, will decide whether the given series is convergent or divergent. Right? We'll again see what we are doing first. The series is summation un. Then you are taking the summation series with absolute terms. Then you are identifying whether the given series, whether this series summation mod un is convergent or divergent using either of these three tests. In case, if you observe the given series is convergent, not the given series, this absolute term series is convergent, then we say the given series summation un is absolutely convergent. Right? If summation mod un is convergent, then we say the series summation un is absolutely convergent. In case, if you get here, the summation mod un as divergent, if you get this as what you call divergent, then you see we use what you call Leibniz test here. Here we use Leibniz test, and by Leibniz test, if you get it as convergent, by Leibniz test, if you get the given series summation un is convergent, then we say this summation un is actually convergent but conditionally. We say it is conditionally convergent. So this is the basic idea in the case of alternating series. This is how we actually give a conclusion about the given series, whether it is convergent or divergent. So whatever the series you are given, now let us spend a few time, some time on, these problems. Looking at those questions, let us identify which is the suitable technique and solve it accordingly. Okay. Look at the first question. Take these questions onto a paper, and then let us, I'll allow you to unmute yourselves. You can also cooperate. You can also communicate to me so that we can identify the suitable technique, and of course, we can try to solve it. All right, see, I'm just moving on to the first question. Right, see, I've allowed you to unmute yourselves. Yeah, look at the series and try to tell me what is the nth term. Anybody? First point, whether it is a positive term series or alternating series.
Positive.
Right. Clearly, it's a positive term series. Good. Then Look at all the terms and try to tell me what may be the nth term. Right or wrong? Try to communicate.
2n minus 2 by n into n plus 1 into n plus 2.
2n minus 2. Is that 2n minus 2 or anything else? Okay, let's think of it this way. You should get these things when you substitute n is equals to 1, and you must get all these terms when you substitute n is equals to 2, and here you will get these things when you substitute n is equals to 3. If you take 2n minus 2 in the numerator, when you substitute n is equal to 1, we'll get it as 0.
2n minus 1, sir.
See, understand it this way. Look at all the numerators, 1, 3, 5, probably the next term is 7. They're all odd numbers, isn't it? 1, 3, 5, 7, they're all odd numbers. When they're all odd numbers, you must remember that comes out as 2n minus 1, right? In fact, you can also think it this way. 1, 3, 5, 7, they're all in arithmetic progression with starting number as 1 and common difference as 2. So if you use this idea, a plus n minus 1, a plus n minus 1 into this difference, d, right? So the first number is 1 plus the difference is actually 2. So we'll get it like this, even if you simplify this, we'll get it like this, 1 plus 2n minus 2, which is 2n minus 1. So when you substitute n is equal to 1 here, you will get 1. Then when you take n is equal to 2, we'll get 3. For n is equal to 3, we'll get it as 5. So that we got the numerator properly. And if you look at the denominator, they are like 1, 2, 3. So that you can understand it is in the nth term, n into n plus 1 into n plus 3. Because you see, when n is equals to 1, it started with 1. When n is equals to 2, it started with 2. Then for n is equal to 3, you see, it started with 3. Similarly, in the nth term, it should start with n only. So that, 1 increased every time. 1 to 2, then 2 to 3, then 2 to 3, 3 to 4, 3 to 4, then 4 to 5. Similarly, here also n to n plus 1, then n plus 2 here. Right? So that's how you can identify the nth term. Now, somebody try to tell me, looking at this un, let me just add a few sentences. While writing, answer for this question in the examination, follow some simple ideas so that you can score better marks. You should not write anything randomly. Add some masala like this. Let summation un be the given series. So therefore, as we understood already, un is equals to, it is 2n minus 1 divided by n into n plus 1 into n plus 2. Right, so this is the nth term. Now, can somebody tell me now what may be the suitable series here? One point, as you told me, it's a clearly positive term series. So we have only 3 options now. What are those 3 options? We may use what you call comparison test or ratio test or what you call nth root test. See, when can we use nth root test? That's the idea. When can we use nth root test? Whenever the nth term has some expression like this, something whole to the power of n. See, we don't have any such term here. When you don't have any such term here, we cannot use nth root test, right? So nth root test is not a suitable idea. Now we have only 2 options, ratio test or what you call comparison test. See, to use comparison test, what we expected, degree of numerator should be less than the degree of denominator. Clearly, degree of numerator is 1 and the degree of denominator is 3. And everywhere you see, we have only linear expressions. Looks like, comparison test is most suitable. But remember, let me also think of what you call ratio test. Right? See, let me tell you one idea here. When you have all linear expressions, look at all these expressions individually, 2n minus 1, n, n plus 1, n plus 2. When you have all linear expressions like this, if you can use ratio test, somebody can try it later. If you use linear, what you call ratio test, you will take this ratio, un plus 1 by un. When you use this, you see, certainly, because all these are linear expressions, when you take limit n tends to infinity to this particular ratio, will definitely get the limit as 1. Because whatever the coefficients you get in un plus 1, the same coefficients you will get in un also. So that when you take the ratio, the same coefficient divided by the same coefficient, we'll get it as simply 1. That's how when every term is linear here in this expression, every expression is linear here, you can understand you cannot use what you call ratio test. There must be different terms so that we may get different values. Okay, so that's how you can understand. Anyway, N through test is not suitable, and even if you use, of course you can use a ratio test. I'm not saying you cannot use it. If you use that, you will get the limit as 1. So when the limit is 1, again you see what we call, we'll say ratio test fails, right? That's how the most suitable method here is what you call comparison test. So to use comparison test, we need to choose what you call one series, auxiliary series, whose convergence is already known to you. Then how can we choose such a Vn here? We'll try to write somehow. We may take some of the terms common from both numerator as well as the denominator, but somehow we should write it as a function of what you call 1 by n. If you can write this as a function of 1 by n, while writing this, you will get something as a product here, right? Whatever the function you will get as a product to this f, that function will take this as what you call Vn there, right? So let's try to rewrite this expression un as a function of 1 by n, and from that you will identify what is Vn. So see, to get a function of 1 by n, I'm trying to take n common from the numerator. So what it is, 2 minus 1 by n divided by, in the denominator you see, I'm writing it as n. I'm not changing this, but from the numerator, from the other term here, you see, we have n plus 1, right? So to get something like 1 by n, I'm trying to take n common from this n plus 1. So that we'll get it as 1 plus 1 by n. Then even from this n plus 2 also, I'm taking n common. So that we'll get it as 1 plus 2 by n. Right? So you can cancel this n. What remains then, you see? 1 divided by, I'm just writing these two terms, n into n square. And if you write the remaining terms, you'll get them as 2 minus 1 by n divided by, in the denominator you can see, 1 plus 1 by n into 1 plus 2 by n. Right? I've written these two n's which are in product as what you call n square here. Then see, it is just like something into a function of 1 by n. So whatever the product, whatever the function you got here in product, that function can be taken as what you call n square. So here you can take Vn is equals to what you call n square. Right? Understand, when you choose 1 by n square as Vn, selecting Vn is quite simple, but the idea is we must know whether this series summation Vn is convergent or not. Somebody tell me whether summation Vn, I mean summation 1 by n square, is that convergent or divergent? Anyone?
Convergence.
Okay, how it is convergent?
Because P is greater than.
We should write that. Right? After identifying what is this Vn, we are going to use what you call P series. Right? So from P series, summation Vn or summation 1 by n square is convergent. Right? So this is because P, right? Always we take this as n to the power of P, 1 by n power P. And what is that P? Here in this case, it is 2. Since P is 2 and it is greater than 1, we'll say by P series it is convergent. Now see, this is not enough. We need to evaluate one more limit. Now, to use comparison test, we need to take this limit. Limit n tends to infinity, un by Vn. Right? So if you just try to evaluate it, limit n tends to infinity, what is this un by Vn? Look at this, all this product is un, right? When you divide all this function by Vn 1 by n square, simply 1 by n square will be cancelled out, right? If you divide all this product by 1 by n square, simply this 1 by n square will be cancelled out, correct? So it comes out as only
2.
Yeah, 2 minus, I'm just writing these terms once again, 2 minus 1 by n divided by 1 plus 1 by n into 1 plus 2 by n. So as n tends to infinity, clearly as we know, 1 by n, 2 by n, both approach to 0. That's how you will get the limit as simply 2, which is finite and of course non-zero. Since this limit is finite and non-zero, we can say, therefore, by comparison test, we can say both summation un and summation vn behave alike, right? But already we have seen, summation vn is a convergent series. Since summation vn is convergent, therefore we can say summation un is also convergent. Right? So that's how you can identify a suitable technique and then you can even solve it. Let me just add few points here. During the last few classes, we have been observing several problems. See, in almost all the problems, we are selecting a particular method, and of course, we are proceeding to find out the convergence. See, we had seen some problems which involve x, right? In the series itself, we had seen, some kind of x, maybe some x power 2, x power 3 kind of things, or x plus 1, x cube plus 1 kind of things. Somehow, we had seen terms involving x, correct? In a given series. Understand, when you are given, a series which involves x, can we solve that problem using comparison test? Right? In the practice, you see, while solving problems on comparison test, we had not taken any question on, any question involving x, if I remember correctly. Right? While solving a question involving x, see, in fact, you see in comparison test, we need to select, one auxiliary series like Vn. If you know this auxiliary series, then we can compare it. But when the series involves what you call x, see, this kind of, simplification is not that easy. So in most of the cases, when the series involves x, that problem can be solved by, in case, remember, if it is a positive term series, the given series is a positive term series, and even it involves x. In such a case, in many of the cases, so many times, from practice, I'm telling you this, mostly you can solve those problems by either ratio test or what you call nth root test. Okay, when the given series, when it is positive term series and even it involves x, in such a case, you can solve those problems by either ratio test or comparison test. Ratio test or nth root test. Right? That's how you can understand when it is a problem on comparison test. Mostly, it doesn't involve any kind of x. Okay, so that's one idea which you can remember while practicing the problems. Okay, now let me just ask you one more question. As I told you, you see, in the examination, in the mid-examination, we are expecting now 4 questions from Unit 4. Right? Let us understand, Unit 5 is not included as of now. So you can expect 4 questions from Unit 4. In such a case, you can expect 2 questions from positive term series and 2 questions from alternating series. Right? Recall, when it is a positive term series, we have 3 options. The questions, there may be a question on what you call comparison test, ratio test, or nth root test. Out of those 3, I'm saying you will get 2 questions in the examination. Okay, mostly, we don't try to give you 2 questions on the same method, isn't it? Isn't it? That's how you cannot expect same topic. Same question on same topic. 2 questions on the same topic. Same method. So certainly you will get a question. 2 questions from these 3 different topics. So suitably, you need to identify a technique, and of course, you'll conclude that. Somebody is asking me from chat box, in comparison test, if you get the limit as 0, see what I'm saying here, limit must be finite and non-zero. What if that limit is 0? Can anybody tell me this?
They do not behave alike.
That's it. It means this, we cannot find the convergence of this series using comparison test. We'll try it by other method or other techniques. But comparison test cannot be used in this case if the limit is 0. Right? So that's a story. And now let me just move on to the other one. Okay, and one more thing, remember, in semester examination, even in the semester examination, definitely there will be one long answer question in the question paper. Sometimes there may be two also, but one question is for sure. And moreover, you see the unit title is actually sequence and series, but I have not included any question from sequences because sequence is a simple topic and you can expect only kind of definitions or simple problems on evaluation of convergence of a sequence. Mostly, in our examination, probably this year, we may not have any short answer type of questions in the question paper. Keeping that in mind, you see, I've not included questions on sequences. Okay, so definitely in long answer type questions, you will get questions on series only. But remember, whatever the question it is, these questions will be given only for 5 marks mostly, right? We cannot expect certainly what question comes in the examination. So whatever the question may be, they'll be only for 5 marks. In such a case, you can understand when it is a long answer question for 10 marks, definitely you can expect these questions as sub questions. Okay, like, if it is a second question, 2A, 2B kind of things, right? So keep that also in mind for semester examination, I'm saying. Now, look at this question. Right, look at the question and try to identify what may be the, first of all, is it a positive term series or a alternating series?
Positive term series.
Absolutely positive, because see, you are clearly given x as greater than 0. Now, can somebody identify what may be the nth term?
X power n.
Okay.
By.
Okay. Please, I'm just proceeding directly, but don't forget to write this statement in the examination, especially summation un. Let summation un be the given positives given series. Then what is un? X power n by
Power n by n plus 1 root of n. Root n.
Look at the series carefully. When you substitute n is equal to 1 in this, we must get the first term. When you substitute n is equals to 1, we should get it as 1 by 2 root 1. Or see, remember one more point I can tell you. Sometimes while identifying this un, we may start n from 0. This is also okay. N starts from 0 to infinity. Or you can start n from 1. But in many of the cases, you see, we take n as an what you call positive integer, natural numbers, right? That's how we take n is equals to 1, usually. But in some cases, when it is not possible, you can even start from n is equals to 0. But here, you must tell me whether you are starting n from 0 or 1.
N from 0, sir. But
if it is 0,
n is only even numbers we should get.
So there must be something then.
Yes.
2n minus 2, sir.
We have done this question, already in the class. Right? See, if you look at all the numerators, first of all, you can understand it as x power 0, then x power 2, then x power 4, then x power 6. When you take n is equals to 1, it must be 0. Then when you take n is equal to 2, it is 2. For n is equals to 3, it is 4. Then n is equals to, for n is equal to 4, it is 6. Normally, since these are all even numbers, you must take them as some 2n. Right? Always 2n gives you even number. Even when you take 2n plus 2 or 2n minus 2, even these things give you what you call even numbers only. When it is 2n plus 1 or 2n minus 1, they are odd numbers. So to get even numbers again, we can take either 2n plus 2 or 2n minus 2. Because we're expecting a 0, when you substitute n is equals to 1, let us proceed with 2n minus 2. Right? If you substitute now n is equal to 1, we'll get it as 0. When you take n is equals to 2, we'll get it as 2. Then for n is equal to 3, we'll get it as 4. Right? So keeping that in mind, un in the numerator now, it is x to the power of 2n minus 2. And see, when n is equals to 1, we have 1 here. Then for n is equal to 2, we have root 2. Then for n is equal to 3, third term, we have root 3. So keeping that in mind, in the nth term, we'll have root n. And you see, prior to that, we have 1 more than what you have in the square root. So here it should be n plus 1. So x to the power of 2n minus 2 divided by n plus 1 into root n. This is what you call n, un. Can somebody tell me what may be the suitable test here? You should not tell me that randomly, but there must be an idea behind that. Okay, let me use this way. To use nth root test, it should be like something whole to the power of n. Right? To use nth root test, we must have un as something whole to the power of n. Do we have such an expression here?
No, sir.
Right? Numerator looks okay, but the denominator has nothing, no term as something to the power of n. So nth root test is not a suitable one. And as I told you a few minutes ago, when your series involves x, we cannot use comparison test. Correct? That's how the only option what you have now is ratio test. Right? You can understand it that way also. So now, since ratio test can be used, what can we do in ratio test? You can just think of it this way. Un plus 1 is what you see. If you write it, I'm just writing it for you, for your convenience directly. It is x to the power of 2n. You can just substitute n is equal to n plus 1. You can verify this. X to the power of 2n divided by, here you'll get it as n plus 2 into square root of n plus 1. Then you see what you do. You will then take what you call limit n tends to infinity un plus 1 divided by un. Right? You'll just evaluate this limit. If I remember correctly, we'll get this limit as actually x square. Now see, when you get this limit as x square, we'll try to take 3 different cases. When x square is less than 1, we say directly the series is convergent. When x square is more than 1, we say the series is divergent. But when x square is equals to 1, by ratio test, we say convergence cannot be concluded. Convergence cannot be given. But we'll try to take that series again when x square is equals to 1. We'll just try to take it like this. If x square is equals to 1, particularly. If x square is equals to 1, we'll just try to rewrite the series again. So in that case, you see, we'll get un. When you substitute x square is equal to 1 here, we'll get un as 1 divided by n plus 1 into root n. Right? When it is nth term, after taking x square is equals to 1, we need to again solve whether this series is convergent or not. Right? See, to find out whether this series, summation un after taking x square is equals to 1, to find out whether this series is convergent or not, again, we cannot use ratio test. We have already used ratio test. You see, this is a special case where the ratio test doesn't, ratio test cannot be used. For that special case, if you use again ratio test, you won't get anything. Again, you will get, of course, a limit as 1, useless. So think of a test prior to that. What test you have prior to that? It is only comparison test. So when you take x square is equals to 1 to find out whether this is convergent or not, now use what you call comparison test. Right? What we do in comparison test, we need to write it as something into a function of 1 by n. So try to take n common from this n plus 1. Right? When you rewrite this, see what happens here. You can write it as 1 by, already you're taking 1 n common, and here is a root n. So if you write these two together, the remaining is 1 plus 1 by n. So when you multiply n and root n, it becomes 1 by n to the power of 3 by 2. So if you take that 1 by n to the power of 3 by 2 as vn, you can find out the solution. Okay, I think we have done already this in the class. Otherwise, you can refer to that ratio test notes. You will find out the solution there. Okay, this is how you can solve this particular problem when it involves x. Let me just look at the other question here. Look at this. Looking at that, can somebody identify what is nth term here? Anybody? Anybody is okay?
N plus 1 by n plus 2 whole power n, sir. In from 0 we can take.
Okay, come again. N plus 1.
Yes, sir. N plus 1 by n plus 2 whole power n.
Okay.
N starts from zeros.
1 point, you see, when you take n is equals to 0, this whole to the power of, it becomes whole to the power of 0, then we'll get the first term as 1 actually.
Yes, sir.
But the other ways, you see, if you just think of it this way, if you take n is equals to 1, we'll get these things as okay. When you take n is equals to 1, you are getting this from this expression. When you take n is equal to 1, we'll get 2 by 3 into x. When you take n is equals to 2, you are getting this term. I think you're right. You are getting correctly. Then for n is equal to 3, we are getting this. All others are okay, but the problem is there with the first one. Anybody have any other idea? Any other idea? Anybody?
1 by 2 plus
Okay. 1 by 2 plus.
n plus 1 by n plus 2 whole power n x power n.
Okay. See, the idea here is somebody from the chart box, you see, they sent me this one. Let me look at this one also. N by n plus 1 whole to the power of n into x to the power of n minus 1. Please try to tell me whether it starts from 0 or 1. Definitely it should start from 1, it seems. Yeah. If you take n is equals to 1 here, we'll get this as 1 by 2 whole to the power of 1 into x power 0. So you're getting correctly 1 by 2, all right. But when you take n is equals to 2, we'll get this as 2 by 3 whole square into x only. Looks fine. 2 by 3 whole square into x. See, we don't have any square actually. We have absolutely only 2 by 3. Okay, right. Understand this way. We have one property, you know. We have one property, what it is. If you add or remove certain terms, some finite number of terms from the given series, if you add or remove some finite number of terms from the given series, then still this convergence of the series remains the same, right? So keeping that idea in mind, if I simply ignore that first term 1 by 2, what if I remove this term? As per the property we discussed, removal of this first term doesn't influence the convergence of this series, isn't it? Keeping that idea in mind, I'll simply ignore this 1 by 2 and I'll take this as the first term of the series. I mean, 2 by 3 into x itself is the first term of the series. So even if I ignore that, even if I include that, this series remains as either convergent or divergent. Earlier, if it is convergent, even after removal, it will be convergent only. Earlier, if it was divergent, even after removal, it will be divergent only. Since the convergence remains the same, removal, I mean, ignoring this term 1 by 2 has no influence at all. So keeping that in mind, I'll take this as un, right? N plus 1 by n plus 2 whole to the power of n into x to the power of n. This is absolutely the nth term un, considering this 2 by 3 into x as the first term. Okay, so that's what you need to understand. Even if you remove some of the terms, definitely there will be few series. I gave you some kind of practice questions on one of the days. You can see in that question, you will find n greater than or equals to 2. You'll be given a series. I don't remember the series exactly, but besides the series, you see, you'll find this condition, n greater than or equal to 2. It means the series actually starts with n is equals to 2, and there will be some first term in the series. You need to ignore that. Whatever the nth term given in the series, that suits only when n is greater than or equal to 2. But for n is equal to 1, you see, you have some other term. That is not actually the nth, I mean, the nth term doesn't give you that as a general case there, right? So anyway, even if you ignore some terms, the convergence remains the same. We can ignore this 1 by 2, and then this is exactly the nth term, n plus 1 divided by n plus 2 whole to the power of n, right? What test can be taken here? What test may be suitable here? When the nth term is exactly like something whole to the power of n, we can understand nth root test is the most suitable thing here. Okay, take this nth root test comfortably, and then find out the limit. Limit n tends to infinity, un whole to the power of n. evaluate how much you'll get the limit. And if that limit is less than 1, we say the series is convergent. And if it is more than 1, we'll say what you call the series is divergent. And if it is equals to 1, we'll say test fails. Of course, when if you get the limit as 1, then of course we'll use the other things. See, in this case, when you take whole to the power of 1 by n, this n will be cancelled out. And if you take limit n tends to infinity, you will get the limit as x. Right? If you just evaluate, we'll get this limit as actually x here. So when x is less than 1, we'll say directly it is convergent. And when x is greater than 1, we'll say it is what you call divergent. And when you take x is equals to 1, you see, we take a special case. We take this series when x is equals to 1. By taking x is equals to 1, we just try to rewrite it. So then in that case, we'll get it like this, 1 by 2. If you take x is equal to 1, 2 by 3 plus 3 by 4 whole square, then plus 4 by 5 whole cube, and so on. Now see, again, if you ignore this 1 by 2, you can understand the nth term un is n plus 1 divided by n plus 2 whole to the power of n. Right? Somehow we need to see which test is suitable here. You can think of now, because we are using initially nth root test, you can think of either ratio test or comparison test to give a conclusion about the convergence of this particular case. Right? Just to think of that. Just move ahead quickly. Look at this. Is it a positive term series or a negative term series? I'm sorry, not a negative term series. Whether it is a positive term series or an alternating series.
Alternating.
Alternating.
Clearly we can find there are sign changes. Correct? So it's an alternating series. Remember, when it is an alternating series, we always start like this. Initially, we take it as summation un. Let summation un be the given series. Then when you are given an alternating series, the second statement here in your solution must be, let summation mod un be the series with absolute terms. Right? Though some of the terms here are negative, we still take them as positive by taking the absolute values. So therefore, you can understand summation mod un is, I'll just write all this series by taking only positive sign. I mean like this, 1 by 2 cube. Though it was negative earlier, I'm taking it as positive now. See, 1 by 3 cube, because we are taking the modulus. 1 by 3 cube into 1 plus 2, then plus again 1 by 4 cube into 1 plus 2 plus 3, then plus again, see, I'm taking plus only, 1 by 5 cube into 1 plus 2 plus 3 plus 4 plus, and so on. So this is what you call now a positive term series, because everything is positive. Now from this positive term series, we need to choose what you call the nth term. Right? Can somebody expect what will be the nth term here? Mod un is equals to, look at the denominators. Everywhere we have a cube, clearly. So something like a cube comes here in the denominator. When n is equals to 1, you see, we should get, am I correct? Yeah. When n is equals to 1, we should get what you call 2 here. For n is equal to 2, we should get 3. Then for n is equal to 3, we should get 4. So in the n plus 1th term, we must get it as n plus 1, 1 more than whatever the value you are taking. For n is equals to n, we should have n plus here, n plus 1. So I'm taking it as n plus 1 whole cube in the numerator. And see, for this cube, see the numerator. In every term, the numerator is 1. So that here also we'll get it as 1 by n plus 1 whole cube. Correct? And then this multiplied by, look at the other terms. In the first term, we have nothing else here. When there is nothing, you can understand probably it is 1. So in the second term, we have sum of first two terms, first two integers. Then in the third term, we have sum of first 3 natural numbers, first 3 positive integers. Then in the fourth term, you see, we have sum of first 4 natural numbers. In a similar way, in the nth term, we can expect sum of first n natural numbers. Correct? Sum of first n natural numbers can be expected here. So that you can understand, mod un will be, this is 1 by n plus 1 whole cube, it remains as it is. And sum of first n natural numbers is n into n plus 1 by 2. So 1 n plus 1 can be cancelled out, and we'll get it as n divided by 2 into n plus 1 whole square. So this is, what you call nth term mod un in the positive term series. Right? Now from here, what you need to do, you see, we need to verify whether this summation mod un is convergent or not. Right? In case we can use, what can we use here? We can use either comparison test or ratio test or what you call nth root test. Certainly, we cannot use what you call nth root test, as as you don't have something whole to the power of n. It looks like, we can use what you call comparison test, because when you take n common from this, we'll get it as n by n square. So we'll get Vn as probably 1 by n. That's one option. Otherwise, you can also use a ratio test. Some of you can try that. If you get the limit as less than 1 or greater than 1, accordingly we'll decide it. In case, if you get this summation mod un as convergent, right? In case if you get this as convergent, then I'll say the given series summation un is absolutely convergent. Okay. Then in case if I get this as divergent, then I'll proceed with what you call Leibniz test. In Leibniz test, if you remember, we'll simply ignore the signs and we'll only test those two conditions, whether un plus 1 is less than un, and the second one, limit n tends to infinity, un is 0. We'll just verify those two conditions, and if those two conditions are satisfied, then we'll say the given series is convergent. If this is convergent here, earlier it was divergent, and after using Leibniz test, we identified it as convergent. In such a case, we'll decide then summation un, right, the initial series is conditionally convergent. Right? So like this, we can identify a suitable test and then we'll use it. Okay. When it is an alternating series, always we should take summation mod un, and then using either of those three tests, we'll first of all identify whether it is convergent or divergent. After identifying that, we'll decide whether it is absolutely convergent or conditionally convergent. Right? So this is what we do in the case of an alternating series. Okay. And have one more question, which is also what you call an alternating series. If you look at this, you see, I'm just giving you an idea. Look at all these denominators. They are like 3, 5, 7. So looking at them, you can identify when n is equals to 1, we are expecting a 3 here. So it is 2n plus 1. Right? When you take n is equal to 1, 2n plus 1 gives you 3. When you take n is equal to 2, we'll get 2n plus 1 as 5. So 2n plus 1 is in the denominator. And in the numerator, you see clearly they are all integers. So we'll get it as x to the power of n. So if it's an alternating series, and moreover, it is the nth term is x to the power of n by square root of square root of n plus 2n plus 1. So keeping those things in mind, evaluate whether it is absolutely convergent or conditionally convergent. Right? So that's